Or like a chat GPT request. Like, oh wait, is request included?
No,
Request? Is it not? No, request is standard.
no, it's not. URL lib3 is standard.
Okay, yeah, but URL and dot requests.
Well, that's not request.
Well, it's not request. Yeah. It's good enough for. I just yes, I would like.
What are you doing?
We're talking about
No.
stupid ways to like solve the line. Because you can do exec and run their compute both or do like a very open AI. You can try to get ChatGPT feature.
Oh. You can use an iframe and just open.
Okay, so we're back with calculus. And last lesson, L'Hopital lesson.
All right.
Yes, it's going to be a fun lesson. Okay, so we'll start this time with what number of lecture?
Last.
No, we should know the number.
Look for lecture and you'll find it.
Probably.
You've written 13,500 words of this, don't you know?
Just in your course, don't push that. Oh, okay,
That's impressive. Yeah, the latest is.
I think not. I think that once I tried and it reduced.
It's 200.
I'm not sure that. Yeah, no, but that's because the font is huge. Lecture 22. Now you got me curious. Let's open the course. I think it's my biggest. It's like 2. Maybe this, I think I had the most number, the highest number of meetings.
It's more course. Oh wait, it's
No, it's not. It takes times to load. It's because it's on the Google Drive, I think. Okay, so this is 230 pages.
And the words are still loading.
Oh, you
Down.
see, that's what I told you.
And in our document, it also went down to like 11,000.
But why? It will.
I think it's
maybe it
removing
was
the latex.
guesswork. He said, I don't know. So that's 11,650. And yes.
Now that
And
you
now,
open the
wow,
window, there
it's
are
almost the
mosquitoes.
same. Interesting. 1130. Okay. Yeah.
Now that you open the window, there are mosquitoes.
Okay, after this exciting discussion, let's schedule a prep session. So, do you have any question?
I wanted to do one last thing.
What?
I wanted to see if the latex that's the one.
All right. So now that's going to go from A to B sine of x plus sine of x plus sine. Yeah. No.
Wait. And if you take it out.
So it all counts as one word. That's not fair. That's not a word. Okay. So this is nothing to do. So the prep session.
I mean, should we do it after?
Tuesday the 29th.
That's sure.
I think that's best.
Our exam is on the 1st.
Yeah, the
Yes.
problem is that we have
Linear on the
28.
27th.
28.
Oh, 28. Oh, right. Oh,
We honestly we don't have time to be depressed. We have to start studying for calculus and anyway.
yeah, no, but the question, I thought it was on the 27th. So the question is whether to do it on 29th or the 30th.
29.
29th, so it's at 1 o'clock.
Wait, is there a 31st of June?
No,
Yeah, July.
July, right?
And yeah, oh wait, yeah,
So it's 1 o'clock until 4 prep session. And Tuesday 29th, so July 5th. Win at 3 to 4. No, not 4. Ah, not 3. 1. Sorry. 2, 4. Yes, that's 3, I think, but I meant 1. And prep. Prep or calc.
We're screwed.
color. No.
You see, he knew it from day one. Took you time to realize
That we're
we're
screwed.
screwed.
Oh, absolutely.
Yes, Thomas is just getting it.
What color is that?
What's the color of paint? Red,
No, but what color did I say?
violet.
Oh, it's orange.
Violence. that's,
Right.
that's the color. Calculus.
What is it?
Are you going to send us an email of where it's going to be or?
No, like I said, I asked you to check
Ah.
with the Maskilot, so it's the same. And try to email me and tell me where it is, or I won't be there.
When when's the someone wrote down when the linear one is? Because I didn't.
we agreed on the 24th.
24th between 3 and 6.
24 between 3 and 6.
Yes.
We should have moved to your office after the break. I mean, during the break.
Whatever.
We can go to the first floor if you want.
No, let's continue.
Wait,
We've
no.
suffered so much that now it would be stupid. It was the suffering would be meaningless. Okay. Yeah, right. So today we will practice L'Hopital's rule. I will teach it as well, but the proof is more or less what I said last time. It was this, and that's part of the proof. The rest I don't prove anyway. And most of what we do it will be practice as to how to use it. So the rule, L'Hopital rule, says as such: given a ratio function f of g such that it is its limits. I say it is. It's not accurate, but fine. Of the form infinity over infinity, or 0 over 0. So that's the main thing. You are allowed to use L'Hopital rule when you have a limit of infinity over infinity or 0 over 0. Given, not give. Then if the ratio, the quotient of the derivative tends to L, so does the quotient of the original functions tend to L. And so why do I simply write that f over g equals f prime over g prime? Because that is not true. It is possible that this limit will not exist, but the ratio of f over g will exist. Okay, so the reason is here because the ratio between the original function is the ratio of the derivative at specific points. So it could be that the limit at a whole will not exist, but there still be a limit on specific points. And I will give an example later. Any questions thus far? So what is the practice thing here? And we will learn 5 principles as to approach the problematic cases. So 1, okay. So 1 is the case that you have f over g, which is of the type infinity over infinity, or 0 over 0, and then you can use L'Hopital. This is nothing new. Next, suppose you have the case of f minus g of the type infinity minus infinity. What would you do then? Then either take a common, right? Common factor out, or do a common denominator. If f and g are fractions to begin with, then you do a common denominator. If they are not fractions, you take a common factor out. Thomas has lost it.
If they're here, we might as well open it there.
Yes.
No, that's not how it works.
Yes, it is.
Okay. 3. When you have f times g of the type infinity times 0, then what do?
You do e to the limit.
No, not that. That's 1 in infinity. Then you do f times g equals f over 1 over g, or g over 1 over f. And the point is, L'Hopital rule is only the first part, only infinity over infinity or 0 over 0. The rest of the cases are meant to do algebraic manipulations such that you will get 0 over 0, infinity over infinity. That's what happens here. Because if f is infinity and g is positive 0, for instance, then 1 over 0 is infinity and you get infinity over infinity. Okay, that's the thing. 4.
Wait, when do we do the e to the?
It's within the list.
Okay.
It's now actually. If you have f to the power of g,
Right.
and if it's of the form 1 to the infinity, then you can use E rule. Which says that f over g tends to the lim e to the power of the limit of g times f minus 1. and if f to the g, and if f to the g is of the type infinity in the power of 0 or 0 to the power of 0, use the log rule, Ilan, which is f to the g equals e to the power of g ln of f. Okay. So we've covered the quotient, the subtraction, multiplication, the power. These are all of the problematic cases. So what is rule number 5? And now I'm thinking about it.
Sorry, and the infinity to the power of infinity doesn't work here.
Infinity to the power of infinity, that's just infinity. What's problematic about it?
Okay.
Everything that is not problematic is not written here. What's 0 to the power of infinity, for instance? It's not here as well.
0.
It's 0 because the power just lowers the expression further down. So rule number 5, I'm trying to think of something because I have in Hebrew a slogan, but I'm not sure if it translates.
Never talk about calculus.
What rhymes with derive?
Survive.
Your
Ah, and don't,
Derive to survive.
yes, don't derive, I like it. Don't derive to survive. It's nice to survive. In Hebrew, it's לא לגזול כמו חמור. Okay, the point is, I like it.
What does ligzol mean?
Derive.
To derive.
נגזרת is the derivative.
Don't derive like a jackass.
Oh,
It's also nice the way you say it.
Kama is it? I thought Kama was like a donkey or something.
Yeah. but-
Jackass.
Yeah,
Ass is a donkey as well.
Oh right, yeah, okay, that's funny.
Okay, so and the thing is, sometimes L'Hopital will not work, but sometimes if you go simply to the derivative, you might do a lot of unnecessary work. And I will show you a few examples. And so just remember not always just to derive. Try to figure out what do you know, some wouldn't it be nices, everything we've learned as well, multiply by the conjugate and take out the common factor, the meaningful, the most, I think the word for it.
The biggest common divisor.
No, not common divisor. When you take the most,
factor.
no, if you have x cubed, then x squared, then you would take x cubed out because it's the largest. I don't know. In Hebrew, I always say משמעותי, but
The most significant.
significant. Yeah, I think that's it. The most significant factor out, stuff like that. You need them sometimes. Okay, so
Greatest common factor.
no, but it's not common. That's even here when I'm saying common factor, it's a bit misleading because no, but it's not common. It's not common. That's the
Dividing by the highest polynomial.
yeah, but the most significant factor. That's what we do. We take the significant factor out. It doesn't have to be part of the other one. You might divide by it, because it wasn't there. Okay. So next we'll just do example after example in order to I've caught the disease as well. I think it knows it's being hunted. Okay. So now we'll just solve a few examples.
Yes.
Sorry, I wanted to
you.
open a window in a closed room.
Why didn't you fix the AC?
I'm gonna go and open it again.
Yes.
No, I'm gonna wait until you kill all the mosquitoes that got in, and then I'm gonna open it.
Here you go, open the window again.
So what is the limit as x goes to infinity of sine of x plus x over x? So first of all, where does the numerator tends to? Infinity. And the denominator?
Somewhere close to infinity.
Infinity, right? So we might be tempted to derive to survive. We do. And
But obviously, that's just 2.
obviously, it took your catchphrase.
I'll take
Obviously,
it
it's
as a
2.
compliment.
Okay. I'm laughing because it's not the limit. But
The limit of sin x over x is 1 only when you tend to 0.
Oh, I didn't see the limit x infinity. My bad, my bad.
yeah. No, but if your size was 0, it also won't be 2. But fine, fine. And in any
Oh, really?
well, no, you're right. No, sorry. It would be 2 if it's 0. No, you're right. Okay. So what's the derivative of the numerator? It's cosine of x plus 1, and the derivative of the denominator is 1. So what's the limit here? What's the limit of cosine of x plus 1 when x goes to? Does not exist.
plus 1.
D and F do not. D and D do not define. Does not.
Do not
Dragons.
this.
No, but there are some abbreviation to not defined.
Do not define.
Do not define.
No, it's Dungeons and Dragons.
Yeah.
Our
Hashtag with D&D. D&D stands for
Fuck that.
what?
Do not fuck. Like,
stands
don't fuck with this.
No.
stands for dungeons.
Mm.
And how do you write it?
Doom-guild.
Dungeons.
Dungeons and
Dungeons.
derivatives. Okay, that's nice. And and or derivatives and dragons, but I think dungeons is better. And
Yeah, more connected to the game.
You're missing
Okay.
a D.
or does I have no do not define.
Do not define.
Okay, and that's the garbage time of the course. Okay, it's not defined, right? And there is no limit. In any case, the limit does not exist. But that does not implies that the original limit does not exist.
Is it 1?
What actually is true, this is not equal to that. And why? I told you in the L'Hopital rule, if the ratio of derivatives has a limit, then it's equal to the original ratio. But if the derivatives ratio does not have a limit, it's meaningless. The actual limit, I'm just seeing how long could I leave him hanging.
No, but I have a genuine question for once.
Yeah, no, I just so the original limit is the limit as x goes to infinity of a sine of x over x plus 1. This is bounded over infinity, and therefore the limit is 1. Yes,
But how do you know if you're surviving? Because well, you see something like that.
you don't know it ahead. It's something you have to think about. You don't know everything ahead and which way will take you the course.
Yeah.
It means that you need to think a bit.
What?
Yeah.
Think that? No
But when you
way.
see that, well, something like that, maybe
No,
it's a bit less obvious than like the first.
No. You would never get the wrong answer. You'll never get the wrong answer. You just need to,
So then one, right?
so if you're feeling that you're going in circles or the exercise become
You
too
have the
complicated, then maybe you need to do something smarter. That's a hint. That's not a rules carved in stone.
No, it's one.
definitely one.
It's a 100 milligrams per 10 kilograms of weight. So
I can't believe you're taking something to mouse gave you. Last thing it
Wait,
came was
did I take
donkey.
out the Xanax?
It
or
was
the-
donkey chocolate. Okay,
What can go wrong with 400,
yeah, that's
400 milligrams of ibuprofen?
yeah.
How much?
You might
400
enjoy class.
milligrams.
Okay. Okay.
0.4, wait, 4.4 grams?
Oh, it's one tablet.
You
Okay.
should take one. I should take two.
I shouldn't take any.
I mean, probably.
Okay.
Wait, is this the last lecture?
Weren't you paying attention to the beginning?
You
No.
He was not
You
paying
were?
attention from the
From
beginning.
the beginning.
Yes.
Straight.
Oh, cool.
Okay, he's consistent. Okay.
Well, my parents used to say the consistency
Yes,
is like a
consistency,
sign of
that's great.
mastery.
Yes.
Master.
If you're going to be a loser, you need to be the last one. The best loser.
Like Don Toretto said, either you lose or you are the second loser.
Yes. Yes. Okay. So that was the first example. Let's review some more. Example. What's the limit as x goes to infinity of x plus 2 to the x over 3 to the x? So where does the numerator goes and the denominator? I wish to still like this. Makes it a bit more complicated. Okay, so we might tempted to derive to survive.
It's 0.
Right, so if we're doing exercises to practice L'Hopital, we're not going to use it.
Yeah, exactly.
Hey, we haven't heard the door make that squeaky sound today.
All right.
It's the air conditioner.
Yeah, whoever was trying to escape died of. So the derivative of 2 to the x is 2 to the x ln 2. Then you have 3 to the x ln 3. Then you have 4 to the x ln 4. Right? What's now? What next?
You derive again.
Yeah.
Wow.
And keep on deriving. Keep on keeping it on. And this is useless. We need
Don't call it useless. It's trying its best.
to take the significant factor out. What is the significant factor on the numerator?
2 to the x.
Yeah, so I'm taking 2 to the x in the numerator times x over 2 to the x plus 1. And in the denominator, it's 4 to the x times 3/4 to the x plus 1. Agreed? which is just like this,
Zero.
half to the x times x over 2 to the x plus 1 times 3 over 4 to the x plus 1. So this goes to 0 because it's a number smaller than 1 to the power of infinity. This goes to 0 for the very same reason, a number smaller than 1 to the power of infinity. But what about that?
That goes to 0 because of the Seidel-Gödel.
So if you learn Seidel-Gödel, but you learn Seidel-Gödel, then
Order of magnitude.
yes, thank you. But we didn't learn it yet.
Oh, stay there, got that.
Seidel-Gödel, yes. But the point is that from the entire exercise, I took one thing that I don't know how to solve yet, but it's one small thing, and I could do that at the side. So what is the limit as x goes to infinity of x over 2 to the power of x? That is actually a good L'Hopital case. Here now you can be happy. L'Hopital. And that's the limit as x goes to infinity of 1 over 2 to the x. 1 over 2 to the x times ln of 2, which is 1 over infinity, which is 0. Okay. So that goes to 0, and therefore this, look below, we'll find out it's altogether 0, because it's 0 times 1 over 1. The explanation is below of this. I'll color it. That's it. Okay. So that's again, don't derive to survive. It doesn't mean not using L'Hopital law at all. It does meaning that it may mean use it wisely. And wouldn't it be nicely? Example. Example. What is the limit as x tends to 0 of
Wait, would we have to do that in our test? We couldn't just say the Gödel.
no, do it. Yeah.
I've been doing it since the start of sequences. We saw it with Near, that's my excuse.
Fine.
Facts.
My excuse is that Thomas saw it.
Because what usually students do, it's say Seidel-Gödel on everything they don't know. And then, oh yes, this is Seidel-Gödel, what's the problem?
It's
The limit is 2. Why? Because of Seidel-Gödel.
But we're not like
it's
ordinary
about-
students.
Yes, yes. Two wars.
prove by reference.
Yeah, for now,
Yeah, prove by triviality.
Yeah. So I saw an interesting funny meme on let's see if I remember it. It has to do with linear algebra,
Oh boy.
but let's see if I remember it correctly. It took me some time to understand why is it even so it was 1, 3, 2, I hope I'm not mistaken. 5, 0, 4, 6.
And it goes to 7.
So this is 5. This is I don't think it's right. Oof. Whatever. Okay. I'm doing one last
Tangent.
no, short of this. And you'll find a meme where multiplying multiplying
How has
two
ChatGPT become?
matrices
I mean.
uh,
ChatGPT is
correctly
thinking
and element by element is the same. I wonder if it works.
There's a little
A meme worthy mathematical. And it thinks that the meme worthy.
Is it?
Yes, how did you find it?
I
By
just
the
look
way?
it up on the internet.
What did you look? Because ChatGPT show me it. I want the numbers.
Multiplying two matrices meme.
Yes. Wow. ChatGPT failed and Google succeeded.
No, Thomas succeeded.
I remembered the numbers, but not in the correct order. Okay, nice, thank you. So it is a bit funny, so I'll show you it. That's 24.
Oh, okay.
You see it?
Yeah.
And so it's not stupid. I think I saw different numbers. Right? I mean, whatever. I think I saw a bit different numbers, but I'm not sure. And maybe it was the same. So if you multiply the matrices correctly, that is actually the result. 3 times 4 is 12. 6 times 2 is 12.
If you multiply
Together is
them
24.
correctly,
But if I'm multiplying 3 by 5, it's 15. 6 by 4 is 24, and 1 by 2. Okay. So yeah, that was a complete waste of your time. Thanks for listening.
Did I tell you the one about pi to the power of 4 is
Hugh Seinfeld outro.
Not now, not now. I wasted enough.
no, the derivative of pi to the power of 4 is 3 pi. No wait,
Ah,
Yeah,
yeah.
pi to the power of 3.
Yeah.
Okay. So next, we will do the following calculation. The cosine of e to the tangent of x, that's enough, minus 1 times the tangent of x over x. You tell me what to do with that limit.
And we look at it.
So first of all, you need to make sure where everything goes to, even if you wish to do L'Hopital, because you're not allowed to do L'Hopital without showing it 0 over 0, infinity over infinity. So we need to plug in 0 everywhere. What is the tangent of 0?
0. Okay.
What's e to the 0? What's 1 minus 1?
0.
Cosine of 0?
0.
Almost.
1.
1. What's the tangent of 0?
0.
0 times 1
0.
over 0. So we have here 0 over 0. What would be your next step?
Look it up.
Giving up.
Okay, would you actually want to derive
No.
that thing? You would not like. That would be silly.
You probably. Oh wait. No. Could we get a
What
question
would
right now?
we do? What would we do? We wouldn't it denies it. We wouldn't it denies it, yes. We reorder things a bit. First of all, that you need to remember, if you have a limit, which is a finite limit and not 0, always put it on the side. Even if you'd like to do L'Hopital on the tangent of x over x, it would be better than doing L'Hopital with deriving that whole thing, which you know its limit. You know its limit. It's so silly. You understand what I'm saying? But here you can do even a bit more than that. What is tan of x? That's the sine of x over x, right?
Oh.
Times 1 over cosine of x. Agreed?
So you can simplify to 1.
So the limit is 1. That was better than deriving it. And why is it 1? Because it's 1 times 1 times 1. Right? This whole thing is 1. This is a known limit. And this is 1. Okay? This is the case with all the questions number 1, and more specifically 1A on my tests. Now you are able to solve them. I'll remind you of the structure of the test in calculus. First question, limit. Second question, series. Third question, a sequence with recursive rule. And then 2 more questions, which are more theoretical or function analysis in general. And each question is worth 22 points if you solve it correctly. Otherwise, you can get no points at all. And
it's 90% of the total weight?
no, 5 times 22.
No, the whole test.
Oh, the final grade. Yeah, I think something of that. 90, 80. What does it matter?
No.
If the
He's already
As long as
figured it
it's-
out.
As long as it's passing.
If no, but that's exactly what I'm asking. So I actually need a 57.
Yes.
Yes. Do not do that because whoever aims for 57 gets
No,
a 7.
no. You figure out like you need like 66, and then you aim for like 76,
You need to aim for 110,
and then you get 50.
and then you get 57. Okay, that's that's the point. Okay, Thomas aims for 200, and he will get 90. And then he
I
will get-
doubt that very much, but thank you for the confidence.
Yes. Okay. So another example. What is the limit as x goes to positive 0 of x times ln of x? Why did I take positive 0? Because ln of x is not defined on the negatives.
This is 1 times 0.
So first of all, what does x goes to?
Ah, no.
0.
Yeah.
And where does ln go to when x approaches 0?
It's undefined.
No,
0, 1,
no.
0.
Ah, 1 over e. There wasn't a
Not even close.
0 or 1.
Let me fix my earlier
Ah,
statement.
minus infinity.
Yes.
Okay.
What?
What?
Look,
Oh.
yes, because
Why do I always remember it from starting from 1?
because you're
Because
always
that's
wrong.
Starting it from
Because you're asking e to the what will give you 0, and the answer is so-called minus infinity.
Because if it's
Ln
negative-
is the inverse of e to the x. So when you're saying ln of 0, you're asking e to the what will yield 0. Well, it's undefined, but if you take something close to 0, so it's e to the power of a very small negative number.
Yeah.
Minus a million. In any case, you need to be familiar with the elementary functions and their graphs and their limits.
So you mean a very big negative number?
Yeah, but it's not a big negative number because it's small. Yeah.
No, it's a small number. It's a big negative number.
If it's a small number and it is a negative number, then it's a small negative number. That's just logic.
But
Okay,
minus
we're
a
going to
million
another
isn't
tangent.
small. It's a big
Minus
negative number.
million is a
No.
small number.
It's a
No.
small number. It's a big negative number.
No, it's a negative big number.
Now you're just confusing me.
But it's always confusing how to say a very, very negative number. Yeah. Okay, so we have 0 times minus infinity, and we can do L'Hopital, that's the third case, I think. Yeah, of the 0 times infinity, I leave one of them in the numerator and the other one goes down to the denominator.
But
Um,
it's a positive 0. How do you do that? Doesn't matter.
doesn't matter. Because my plus minus the fraction, you have arithmetics of limits with minus or plus, right? You don't care about the minus at all.
So,
And
but you have to do it 0/0, or it doesn't matter.
no, either one of them, because it's either 0 over 0 or infinity over infinity or infinity over minus infinity. Ah, you mean it does have to match. So it's plus minus infinity over plus minus infinity. Yeah.
So by your definition, is minus 0.00001 a
Sammy!
very big,
We're going on a tangent.
a very big negative number?
If it's infinite times 0, then it's 0, and it's not positive or negative.
I never said that. I just said 0.00001.
So what you said again? Okay, so
It's very negative.
I'll take that as my answer.
yes, it's a very negative. Your opinion is negative. Okay. It's negligible. Yes. Okay, so the numerator goes to minus infinity, the denominators goes to infinity because it's 1 over positive 0, right? So now we can finally L'Hopital it. I think it's the first. No, we did one L'Hopital before, and we get x to x goes to positive 0. Of the derivative of ln of x is 1 over x. And the derivative of 1 over x is 1 minus 1 over x squared. What next?
L'Hopital again.
What? No, you don't.
No,
That's derived to survive. And in Hebrew, it's more insulting as well. It should be. You can do L'Hopital again in
it's
perpetuity. It will be silly, but you ought to simplify it a bit and find out that's the limit as x goes to 0 of minus x, which is 0.
it's negative 0.
Now I'll give you an example. It does tend to 0 from the negative. That's true. Look at it. X ln x. X goes to 0 from below. And you will also have the knowledge to answer what is the minimal value of these functions and where does it decrease, where does it increase, how many times it passes the x-axis, right? Now we've learned calculus and we can answer all these wonderful questions.
Yeah, but do we want?
I've listened to calculus. I don't
Do you
how
know
it
what that
works.
symbol says, Thomas? Just do it.
Don't let your dreams be dreams.
Okay.
Oh, it's very central. I write this down. It'd be incredibly fun.
Yes. I never had students tattoo a graph of function before. It'd be a good story. Okay. But I do not suggest it.
It's not legal advice.
Yes.
People do tattoo like their arm. This is
Yes.
a thing.
Yes.
I'm not gonna do
That's
it
not what I meant anyway, but yes.
unless you guarantee a passing. I don't.
Then I'll find the cheapest tattoo parlor in Israel. Could you tattoo my eyes? Okay.
That's a good story. Why are your eyes like that? I wanted to pass that.
What is the limit as x goes to infinity? This x root of no, the ln x root of x.
That sounds horrible. It's
No, but that's a
So first of all, In all the cases I've shown you before, I didn't mention anything about roots. So the first step you do is make it into power. So it's x to the power of 1 over ln of x. Do you agree about that?
Yeah.
Now when you have powers, you can classify it. The x in the denominator, in the base of the power goes to infinity. And where does the power go to?
0.
0. So we have infinity over 0. And what we do here is ln, e to the power of ln.
It left it.
That's the limit as x goes to infinity of e to the ln.
An anime fun.
Sure.
I said it's the garbage time of this. Of course. Yes. So like I said, in case number 4, when you have the powers, you either use the E rule if it's 1 in infinity, or you use the ln rule when you have the infinity to the 0, 0 to the 0. Tomas.
Yeah, so now we take out the 1 over ln of x.
So that's the limit as x goes to infinity of e to the power of 1 over ln of x times what?
Ln of x.
Times ln of x.
Just 1.
Yes, so
Okay.
this, I'm proud of you, Thomas, because I gave it to an engineering class some times ago, and like 150 students, like half of them did L'Hopital here. The ln of x over ln of x, that's infinity over infinity, and they did L'Hopital. Yes, but that's
Those are the people building our bridges.
yeah.
That's very.
To be honest, they're not. They're not building bridges. I have no idea who is building bridges. Probably
people in Tel
not
Aviv.
Israeli, but the engineers here are doing the same thing as you. You come from different funnels into the same high-tech grinder. Okay, so it's e to the 1 and
Everyone has long socks.
and 1. And what is the limit? E. Thank
Infinity.
you. So, can anyone tell us what is surprising and weird about that example?
Why is it e?
No,
The fact that
fine.
it cancelled out for like 0 reason.
What would have happened if I asked for the limit as x goes to 5?
Oh, it doesn't matter.
It doesn't really matter because I did use infinity to the 0 as an excuse to do the ln rule, but I didn't have to. E to the power of ln is always allowed, right? And it always comes out e. We never actually used the fact. The students in engineering did use it because they did L'Hopital for ln x over ln x, but it wasn't, they didn't have to. So it is a rather interesting example. Watch the following function. Does anyone guess how does the function look? What does the function? Yeah, it's a constant function, x to the power of 1 over ln x.
It's up.
Right. Yes. Is simply
Whoa.
e.
Oh, but it doesn't go.
And what does it have here? And it's so false. It says that when x equals 0,
Maybe it's for the other function.
the value is 1.
Maybe it's for the other function.
And why is it? No, for both of them it's the same problem, but it's not. Because that point appeared whatever. But that is false on so many levels. Because when you apply 0, well, I don't know if many levels, but when you apply 0 here, the ln is undefined, right? I wanted to say that the fraction is undefined, but the limit is actually minus infinity, 1 over infinity is 0. So it's 0 to the power of 0. And again, it boldly claims that the intercept is 1. No, it falls on every level because the limit is e, because the function is e. I really wonder why does it claim that the intercept here is 1. It's obviously a false statement, but it's unreasonable as well.
What are the points so random?
What?
What are the points that it shows?
It's extra moves.
Right?
Extra move here, extra. That's a good meme as well. Like you get an extra move and you get an extra move. Yeah. No, that is weird. It's this what happens when you let computer science bachelor degrees actually operate computer science. That's the way it looks in the end.
This is
Because it was not for a grade. It
this
was
is
only for a salary. Ah.
this is real computer science made by real computer science.
My mind's
Exactly. Exactly. Okay. Sorry, I didn't wish to be racist again. Computer science guys.
It's
Math,
not racist if it's
No,
right.
it's fine. We
Yeah.
deserve it.
yeah, no,
No,
math major students would not do such horrible things at their jobs
No, they would
What
they would
jobs?
they would initialize
because they don't have a job.
they would
Yeah, exactly.
no they would
They
initialize
never burn their burgers at McDonald's. Okay.
they would initialize a matrix with recursion instead of a loop. That's what math
Oh.
majors.
Yes. It was not funny, Thomas.
No, it's
Okay,
real.
I felt need to say that. Okay,
This lecture is just.
yes,
Of the rails.
yes. Okay.
When is it not, to be honest?
I
What?
mean, it's just like.
Oh, when it's not. I was trying to say when I'm not honest. Okay, I'm always honest. Okay, example. What is the limit as x goes to 0 of x to the power of x from the right? So it will be defined. So here we have 0 to the power of 0. So again, we do the Elan rule. That's the limit as x goes to 0 of e to the ln of x to the x, which is the limit as x goes to 0 of e to the power of x ln of x. But that is a limit we already calculated before. And in the test, you need to calculate it again. But specifically now, we did it a few examples ago. What was the limit here? 0. So here,
By reference.
yes, above,
Proof by reference.
it's e to the 0, which is 1. Okay,
Yes, about 200 pages.
I've got a question.
it's here. It's two examples above.
Joke.
Yes. Yes, Sam.
Why?
Because.
Hang on. Would we ever get a question where f to the g is a different, like, you know, the rule f to the g is like the limit of that goes to 1 to the infinity.
Yeah.
Would we ever get a question where it's 2 to the infinity?
No, why? Because what is 2 to the infinity?
Yeah.
It's infinity.
Yeah.
I listed all the problematic cases above. See, everything else, it's not problematic. Okay. So you
Did
could
you
get such a limit.
did you list
The
zero to-
answer is infinity.
Did you list 0 to the infinity? Yeah.
That's not problematic. That's not a problem at all. Yeah, because half in the power of 1,000 is smaller than half. A number smaller than 1 to the power of a number bigger than 1 is smaller. Okay, next. What about the limit as x goes to 0? You know what? Let's do that. It's funny because it has to do with what you just asked about. Square the x root of x. Not exactly.
So
Yeah.
zero
There.
to the power of infinity.
Yes. It's
One.
I
No,
don't
no.
think I'd notice it. It's weird.
No, wait, but if it's zero to the power of infinity, it's just zero.
Yeah, I agree, but I thought of doing this. What I thought of is I was sure I was going to do the x root of x, but I wasn't sure if I'm going to take x to 0 or to infinity. And I usually take it to infinity. I will do that as well. But when taking it to 0, it's exactly what you asked about. And I don't remember that I've seen it before. Although it's a rather trivial example, but it's a good one.
Thank you.
It's 0 to the power of 1 over 0 plus, which is 0 to the power of infinity, which is 0. That's you look at it, it's x to the power of 1 over x. Yep. At 0, it goes to 0.
That's a weird graph.
Yes. Which graph is not weird in your opinion?
A constant number.
Yeah.
Rough races.
Sounds like racism to me.
Example.
Graphs.
We don't care. We don't care how they look. Just the color.
And now x goes to infinity of the x root of x. So it's the limit as x goes to infinity of x to the power of 1 over x, which is this time infinity to the 0, which makes us go Ilan, which is the limit as x goes to infinity of e to the ln of x to the power of 1 over x.
Which we already did.
No, this time we did not. Which is the limit as x goes to infinity of e to the power of ln of x over x.
Which we already did.
No,
What do you mean no?
Because
Did
we
we
did
do that just
zero.
above?
I mean that you're wrong.
Have I just not been paying attention?
Where? We did ln of x over ln of x. We did x times ln of x.
What was the no further up?
We did x times ln of x. Ln of x over 1 over x. You are racist against function. They all look alike.
Damn it.
Okay.
The racist lecture.
So what's the limit as x goes to infinity of ln of x over x?
It's infinity over infinity.
It's 1.
So infinity over infinity, which we could do L'Hopital. And we get the limit as x goes to infinity of x goes to infinity of 1 over x over 1.
Which is 0.
0. So this is e to the 0. Right. No.
I would have 100% just written 0 because of orders of magnitude.
We get 100% to 0%.
Why? We saw this in class. We
See,
actually
I
did.
said it was 1.
Yes, there was one there. We saw everything in class. The point of the test is to make sure you understood what you saw.
We saw the very end of time during class.
Yeah, but we're not going to rewrite all the proofs you said. You
Thomas
said.
said nothing is original in this test. I saw everything already. And then he will come out and sprat out of the class. The test room. example.
Ask ChatGPT answer.
What is the limit as x goes to infinity of the square root of n plus 1 times sine of the arctangent of the square root of n?
You mean X?
Oh, right. Sorry. X.
No, he means n.
Yeah. Cosine the arctangent of the square root of x.
Um,
Care to guess?
1.
undefined.
You put
Let's check if ChatGPT is able to calculate it.
it's probably
Arctan is
It's
not
probably
1/10,
infinity.
right?
I'm gonna guess
No.
infinity. Why not?
No, I told him not.
Yeah.
You are not because it's not the correct answer. That's such a simple question.
Is that what he
Oh
said?
no, but I made a mistake. Oh, sorry. The power of x.
What?
I forgot it.
Uh-huh.
Such a box. Sorry, that was the question.
Oh yes, this makes it much simpler.
Even better.
Huh? Where would Arctan go to by halves?
So it's e to the minus half,
Of course.
and it's actually the answer.
I should have none.
Yes, and
So close.
What do you mean?
I said 1.
That's
You said infinity.
I said 1 first.
Yes. Okay.
uh,
So what do we do with such an example? It's actually an example that showed up in some. I'm helping students with their homeworks, so it was in some homework, and they saw. And it wasn't the exercise. It was just during the exercise I had to calculate this limit.
this is headbutt too, or what?
Yes, but it doesn't matter. It's the ability to calculate the limit is Chedva 1. So the question is what to do with this horrible thing.
Right.
So like we said, I assume that we for the rest of the class we will handle this limit. But let's try and do it. So first of all, we need to make sure where is everything going. So the square root of x plus 1, where does it go?
Anything.
So that goes to infinity. And what about the arctan? It would be too cumbersome if I'll write everything here. I'll write it on the side. The square root of x plus 1 goes to infinity. The arctan of the square root of x goes to the arctan of infinity,
Which is obviously by halves.
which is half of pi. Why? Because arctan is the inverse of tan, not 1/tan. And you're asking when does tan goes to infinity? And the answer is when x approaches pi/2. And again, you need to know the elementary functions. So arctan looks like
Wait,
this.
arctan counts as an elementary function?
Yes.
Yeah.
Interesting.
All the
The
same
inverse
functions.
of tan. All the elementary functions and an inverse of an elementary function is an elementary function. Okay.
Is
So-
1/10 also an elementary function or no?
It's 1/10.
It's
It's-
actually cot.
Yeah, I think they took it out of the matriculation. No one actually uses cot ever. I don't know
Did
why.
anyone
it's-
use sec or cosec?
That's in the academia in general, yes. In Israel, I think not so much, maybe in engineering. But cot, I never caught anyone use it. So y equals pi/2, you see that's the limit of arctan, and that's because if x is between -pi/2 to pi/2 tangent, because that's the tangent function. And by the way, the connection between a function and its inverse is always a mirror image with y equals x. So that's tangent, that's the tangent function, that's the arc tangent, whatever. So in any case, it's pi/2. So what is cosine of pi/2?
0.
0. So this goes to 0. And what is sine of what is sine of pi/2? That's 1. So we see that this now I can write it here. So this goes to 0 infinity, sorry. This
It's 1 to the
it's 1 to the infinity, exactly. We don't know yet, but it's 1 to the infinity. And this goes to 0. So we don't derive to survive, even though we don't even know what to derive here. But my point is that we will handle these two separately than this one over here. Okay? So first we will try to calculate the limit as x goes to infinity of the square root of x plus 1 times the cosine of arctan times the square root of x. Now, a disclaimer, I'm not sure we'll be able to actually solve the limit, and I'll tell you why. The solution I know to this question was to use trigonometric identities to simplify it. And when simplified, it's much simpler to calculate. So I will try for a bit to go about it this way, but if it won't work, then I will use the simplification using trigonometric identities. Okay. So, but still, what is the brute force way to go about it? So this is infinity times 0. And what do we do with infinity times 0? We put 1 in the denominator, and the other one we take down to the numerator, the other way around. And so let's try to put infinity, sorry. We'll leave the cosine above. And we'll put the square root of x plus 1 below. Okay. Now the numerator goes to 0, that in infinity. What? Oh, no, sorry. 1 over. 1 over square root of x plus 1, sorry. So the numerator goes to 0, the denominator goes to 0, so we can do L'Hopital. And we get the following. The limit as x goes to infinity. So what is the derivative of the numerator? So it's sine of arctan of square root of x. That is good. Why is that good?
Because it's what?
That
One?
goes to 1 exactly. And like I said, don't derive to survive. That's something we already know. We put it aside. We'll
Negative sign. Mm-hmm.
right. And let's just write -1. You're right, it's negative sign. Okay. Below we have, and what's the derivative of that? So it's -1 over x plus 1 times the internal derivative, which is 1 over 2 times the square root of x plus 1. And we need the internal derivative here. What's the derivative of arctan? Whatever. The derivative of
Feels like
arctan is
tan.
1 over 1 plus
Tan.
square root of x squared, which is x. And we have the last internal derivative, 1 over square root of x. Easy.
Over square root of x. Is it not 2x?
2x, thank you. Thank you. Okay. And believe it or not, that's not that horrible. And the minus will be canceled out. Let's order it, reorder it. And so minus and minus cancels out. The sign of arctan I'm putting aside because I know its limit. Next, what do we have here? X plus 1 and x plus 1 are canceled out. We're only left with 2 and 2 are canceled out. We're only left with the square root, believe it or not, I'm surprised a bit, of x plus 1 over x.
That's to 1.
Which we can simplify as that. So the limit is 1. So you just need a bit of perseverance and sometimes to solve it.
And to remember the fact that we haven't finished the question yet.
Yes, but that you don't have to. You don't need to. But we took a huge step. If it was 0, then it may have been problematic because the remaining thing could have been infinity and then they will fight. But because it's 1, then it's easy. 1 and the last one will be the limit. And it's ought to be 1 over the square root of e, which is surprising yet true. So we go here. So now we have next, we have the limit as x goes to infinity of sine to the power of x of arctan of the square root of x. That's 1 to the power of infinity. We use the e rule. And that is e to the power of the limit as x goes to infinity of the power, which is x, times the base of the power minus 1. So that is all we have to solve. Easy.
It isn't none of that. No.
Isn't it 0?
No, the e rule has no line. It's the power times the base minus 1.
Isn't it x times 0? So it's just e to the 0.
But what is x? What's infinity times 0?
Ah.
0.
Yeah, I was sarcastic when I say easy. So it's sine of arctan square root of x minus 1 over 1 over x, which is 0 over 0, and we can L'Hopital it.
mention your surname that you used it.
I think it's just the hospital, it's fine.
Yes. And we get the limit of x goes to infinity. Oh, what's the derivative here? So sine is cosine of arctan of the square root of x time and 1 over 1 plus x time times 1 over 2 times the square root of x. And below we get minus 1 over x squared.
Minus 1 over x squared.
The derivative of 1 over x.
Mm.
Agreed?
Yeah.
Cosine of arctangent of x is 0. So, okay, first of all, let's reorder it a bit. So that is the limit as x goes to infinity of x squared times cosine of arctan of square root of x over 1 plus x times 2 times the square root of x.
Yes,
Agreed?
absolutely.
Okay. What can we do here that will make our life a bit easier? We'll take out the common factor here.
Yeah.
So don't drink and derive. That's their slogan. So x squared over x squared times, here you have the cosine of arctan of square root of x, and below you have the wait, just so I won't make a mistake. One over the square root of x.
You like a negative somewhere, but yeah.
I didn't finish yet. And what we are left with is that's and that. So we're left with 1 plus x below and above. Just a second, I won't do it quickly. I made a mistake. Sorry. I'll write it again slowly.
You on the one before, you didn't put a minus for the
Oh, in general, you're saying, I mean, oh, I see. Okay, yeah, I'm missing a minus altogether. So x squared cosine of arctan of square root of x. Below, I'm taking x out as x square root of x times 1 plus 1 over x times minus 2. Okay. And this equals altogether the limit as x goes to infinity of so x squared over this, all that remains is the square root of x times the cosine of arctan of the square root of x over minus 2 times 1 plus 1 over x. Okay, so this goes to minus 2. I don't care about that. I just need to calculate the limit above. And another trick that can shorten a bit of our time is doing the limit as t goes to infinity of t cosine arctan of t. Because if it's the general limit for anything that goes to infinity, once we plug in the square root of x, it's a specific case. So that is as infinity times 0. So that's the limit as t, x by mistake. T as t goes to infinity of cosine of, we are nearly done, of arctan of square root of t, no square root, of t over 1 over t. And now we do the derivative. So what is the derivative? The limit as t, just right, it's 0 over 0. We can do L'Hopital. And we get the limit as t goes to infinity of. So from above, what's the derivative of the cosine? It's minus sine of arctan of t times 1 over 1 plus t squared over 1 minus 1 over t squared. And here, if you can notice, it's not hard. Why? Where does sine of arctan goes to?
-1.
The sine itself is 1.
Yeah.
And I'll just rewrite it. It's the end. It's even within the time limit. I'm surprised. And limit as t goes to infinity of sine of arctan of t times t squared over 1 plus t squared. Where does t squared over 1 plus t squared goes to when t goes to infinity?
1.
1. The whole thing is 1. So this is 1. The numerator here is 1. So this whole thing goes to minus half. Below. So, and this was the limit here. So this is e to the minus half. No, don't write it here. So altogether, ChatGPT did it quite fast. Altogether, but maybe using the trigonometric identities, it would have been a bit easier. Altogether, I'll just copy the limit, and we calculated it. The limit of this whole thing goes to is e to the minus half. And on that note, I'll see you guys on the prep lesson. Thank you very much. Have good luck.
What are they to finish the semester? No work on mosquitoes. That limit that's going to give me nightmares.
I think it's time for a beer.
Only one. What day is going to be the practice session for linear? I wrote it down. Okay.
Yeah. It kind of cheated, by the way, the ChatGPT said sine of theta to the x is almost approximately this.
I mean,
It didn't get the right answer, but it wouldn't get
I dig it.
graded in a test for that answer.
Come on.
It's guesswork.
Hey, if it's stupid but it works, it ain't stupid.
That's not true at all. Oh, but it was a nice limit altogether. You see calculus at its best.